We are looking at the revision 2 of class 11th for the C++. Functions. Function is nothing but statements, a group of statements that is going to perform certain action, and performing certain action and also returning some value, may not return some value, but it will perform some of the other action. So we have built-in function, that is the library functions. So these are already there in C++ in the header files, and we can directly use these functions. We don't have to give their definition because the definitions are already built in. That is, you will find it in the library functions like the sqrt, like the toUpper, like the isDigit. So these are some header files, some of the other files and functions which we generally use. Like in stdio.h, you find getAs, putAs, ctype.h. This is a character type function. This is for string related function. This is a math and standard library like randomize, random. So for string we have str, cpy, str, upr, like this. Mathematical you have absolute, value, square root and cos, sine, all these. For C type, to lower, isDigit checking can be done. So randomize, what this function does, this function will give you a seed value, okay, and also an algorithm in order to help the random function to generate the random numbers. So this seed value, it can be taken from the system, current system time also. So for this randomize, as we said, that this function is providing the seed value and also the algorithm to help the random function to generate random number. So this is a random. Inside this function helps an integer parameter, say it is an x, and generates a random number between 0 to x minus 1. Please understand, 0 to x minus 1. That means if you have a random and you have inside it 7, this is going to generate between 0 to 6. 0 to 6. And in order to generate the random number between say lower and upper limit, what you can do is you can use the formula called random. This is upper limit, this is lower limit. So u minus l plus 1 plus n. This u is the upper limit, l is the lower limit values, in between which we need to find out the random values. For instance, if you want to find random numbers, say between 10 to 100. So what we need to write in this, we need to write random. This is u, that is 100 we are going to take, L we are going to take 10, then plus 1 and L again 10. So this will generate random number between 10 and 100. Then we have user defined function, that is the function which we or you have to define, or we have to make by ourselves. The function which are user defined, that is we are going to define it for certain purpose, for performing some functionality. For using this user defined function, first we need to define it, then we have to use it. That is, we have to give the proper functionality or the code inside that function, and then we use it. So declaration of the user defined function is something like this. This is the function name, and prefixing it is the return type, and after this, following it in the parentheses are the list of formal parameters. Inside this, you will have body of the function. That is simply the statements, nothing else. Then how to call a function? Whenever we call a function, we have to provide actual parameters. That is, we are trying to send the actual parameters that should match the formal parameter which you have given in the prototype, or you can say the formal parameter list in number, type and arguments. So number, type, arguments of the formal parameter should match the actual parameters. I'll show you. I'll tell you what formal and actuals are. These are the formal parameters. If this is a function, say you have made a function addition, this is the return type, and these are the formal, this A and B, these are the formal parameters. Now this is the formal parameters, and when you're passing 5 to A and 3 to B, these are your actual parameters. These are your actual parameters. So you're passing the actual parameters here, and when we add it, So simply whatever you have written, the result will be returned to Z, and you can now print or use Z. So here also this Z will get the 5 plus 3, that is 8, because this is addition. Now this function has to be written by ourselves. So we have the function name, then we have list of actual parameters. This is the simple syntax as similar to the library function. So just take a program. We have hash include iostream.h. This is our function addition, and this is the return type, and these are the parameters. Now we are trying to give the definition of the function. So a, b, and we say we have taken a temporary variable r, and we are adding a and b and providing it to r, and we are returning it. So this integer before addition is actually signifying that you are returning a r, that is the addition result of a and b. So when we come inside main, we take z, any arbitrary z, and this function has to be given like this: addition 5, 3, that is you are passing the actual parameters. These are the actual parameters for these formal parameters. So z will give you a result, and this z can be printed anytime. The result is 8. Now there are two things: call by value, call by reference. Now you have say x equal to 3. Now you say x plus plus, right, in the function. This 3 will become 4, but you don't want this x to become 4. So for that, means original value you don't want to change. For that you use call by value. But if x equal to 3 and you say x plus plus, x has to become 4. You want the actual value to be changed, which is being passed. For that we use call by reference. So call by value, in the call by value, we pass the arguments to a function. It will just copy the value of actual parameters to the formal parameters. So they are just copying the value of the actual parameters to the formal parameters. That is, it will create, the argument will create its own copy. So any change, any modification that has been done to the actual parameters will not be reflected, right? And in the case of the above program, that is the addition program we have just seen, is an example of call by value. But now, this call by reference is having a different mechanism. So you want to change the actual value. For that we don't pass the value, but we pass the reference. That is, this is the memory location, x is there. So we don't pass x. We pass m% of x, that is the address of x. That is, we pass the reference of x. So whatever is inside this, we pass the reference and then change. If it is changed to 4, so the actual value will be changed. That is, in call by reference method, the call function do not create its own copy of original values, as you see here. It will not create its copy. It refers to the original value only by different names, like the reference, as I just said, m%x. So the call function works on the original data, and any change which is being done is reflected here, and unlike the case in the call by value. So this is the example of passing parameters by reference. You see, this is a main. We are trying to pass 1, 3 and 7. We are trying to print it, but here is a function called duplicate. Let us see what is going on in duplicate. In duplicate, it is not returning anything, but the x is given here, but as m% receives it, that means you are passing the m% or the address of 1. So now you are changing it or multiplying the value with 2. A star, this means a is equal to a into star, a into 2. So what you are trying to do, this will be equal to 1 into 2. So you will get 2 here. X will be 2. So actually x was like this. X has a position, 1 was there. Now you pass the reference of x, that is m% x. So reference of x. Now a is a reference, actually a and x can be referred as the same name. Now when you pass 1 or 3 or 7, when you have a location here and 1 is there, and you are changing, you are multiplying x with 2. So this value will become 2, and when you print x, x is now having value 2. So the m%, this is address of operator, is specified that the corresponding arguments are to be passed by reference, not by value. So this is how it is done. So this duplicate x, this is the actual parameter, is goes to this point, y goes to this, b, and z goes to c. Constant arguments. In C++, we have constant argument. This constant argument means we don't want this argument to be changed. So in order to make a argument constant, we just have to add one keyword, that is const. This const, it signifies that this function will have certain values inside it as an argument, and it is constant, so you cannot change it. This qualifier const will tell the compiler that the function should not modify the argument in any case. Otherwise, the compiler is going to give you an error. It will generate an error when this condition, if you happen to violate it. Default argument. Now, say in a banking system, the interests generally don't change for quite some time. So why to give again and again or pass this interest rate? Rather, we can just have a default value of that. So here you just see an example. We have a function called interest. We have principal in time. But in this rate, we are fixing it. We are saying float rate is equal to 0.70f. So even when we call it this principal 5600, time is 4, but we are not giving any value, any third parameter. So automatically by default, the rate will be taken as 0.70 in the program. So C++ allow us to assign the default values to function parameters, which is very useful in case of matching argument, which is actually not passed in the function call statement. See, here we have not passed it at all. And if you pass it, that will overpower this 0.70. In case, if this would have been 5600, comma 4, comma say 0.6, so this 0.6 is going to overpower 0.70, right? So the default value are specified at the time of function definition, right? So this is how it is done. So the next one is formal parameters. So what is formal parameters? This formal parameters, what the in the definition, function definition, where you give the parameters which appear in the function definition, these are called the formal parameters. And when you are actually calling the function, at that point, those parameters are called as the actual parameters which are actually going to the function. And we can have a function with no return type. We use generally void for that, because the function can only perform printing, so it is not returning any value. So in this case, we should use the void type, and this is a special specifier void that indicates the absence of a type. Then we have a return statement. So return statement in a function, because function does some work and it gives you value, say it is adding a plus b and it is returning some z. So this z is returning, so you have to return it back to the main function, because function is just a block of statement which does some work, so it has to return some value. So the execution of this return statement, after this the function will terminate, that is, it will exit, and the control is passed back to the calling function. In most of the cases it is main, so the transfer control back to the operating system, right? So this return statement also returns a value to the calling function, so it is returning the value. The result is returned, and the syntax is simply return and that value in the parenthesis. What is the scope of the identifier? See, the part of the program in which the identifier variable or the value can be accessed, okay, can be accessed is known as the scope. What is the scope of that identifier? So we have four kind of scope. That is the local scope. In the block, only in the braces, the identifier declared in a block is called the local, is the local to that block, and can be only used inside these braces, not outside this. The function scope, again the identifier declared in the outermost block of the function, and that is where the function starts. This has a function scope. Overall function and the content inside the function can use this whatever you have defined inside a function. While the file scope, that is the global scope, the identifier has file scope or a global scope if you define it outside all the blocks, okay, and it can be used in all the blocks and functions. Then we have a class scope. When we have a name of the class member, this has a class scope, and this is local to its class. So along with scope comes the lifetime. So what is the lifetime? This is the time duration, that is the time interval for which a particular identifier or a data value it lives in the memory. So the time it lives in the memory is the lifetime, right? Then we have arrays. So what are the arrays? Arrays are simply, what you can do here is, you can have, say, one variable for some name, or you can say age of students in your class, but you have 50 students. So you can have 50 variable, or rather than having 50 variable, why not to have just one array name, and we can have 50 positions here. So this array is just simply like this. You have an array name, and this is the size. This size is simply 50 here. So this whole the array, or you can say the contiguous memory location, one by one of 50 location is given by the array. So you have a data type, all integers, that is your age can be put in here, and you have an array name with size, and return type is data type. So not return type, but the type of the array is the data type. So I'll show you with an example. When we work with one-dimensional array, that is, this is only one dimension. So we have just one row, contiguous locations. So the general form of how to read, we have to put a loop for reading elements of the array, 1D array. For that, what we do, we start with 0, we go up to size -1, that is I less than size, right? So array always starts with 0 subscript and goes up to size -1. So if this z is a size, it goes up to size -1. So we just see out, that is, you enter some enter array element. This is how to read, and you can just see in with array name with a subscript. So generally processing part may be included with the loop for reading or printing. Otherwise you can do another thing, that is a same type separate loop may be used for processing. So this is the general form of for loop for printing. Now this is for reading, this is for printing. So 0 to, again, size -1 we go, that is I less than size, and we just see out array, whatever is the array name with the subscript. How to declare the 2D array? Now 2D array, see, this is the array name, this is the number of rows and columns. So now you have, say, age of your class, and you want to have the age of other section also. So these are the rows and these are the columns. So these are the data array name with rows. These are the rows. So this is row 0, row 1, row 2 likewise, and this is the column 0, column 1, column 2, and likewise. So this goes up to r-1, and this goes up to r-1, and this goes up to c-1. So this r represents the number of rows, c represents the number of columns in the form of 2D array. So how to work with two-dimensional array? We have to use two loop. Why two loop? Because first we have to go to a row, that is one loop for the row, and then we have to go inside the column. So first is going to a row, then to the column. So this is a general form for reading loop for reading elements in a 2D array. We go from 0 to r, this is the row. We enter the first row, and then we go to that column 0 to c, and then we can just read from it. And if you want to print the element, this is how it is done. This is for going to the row 0 to r, and inside this we come to the each value of the column, and we print the names or whatever inside. Of course, the r and c are representing the number of rows and columns. How to define a structure? See, array cannot have multiple data type. So we have structure, and this structure is actually the basic building block of class, which is the heart of any object-oriented programming language. So here, when we define a structure, we use a keyword called struct. The name is yours, means you can give the name by yourself, and then we have different data types. So multiple data types can be given, and followed. This is inside a braces, and then we have a semicolon. So this is how to declare structure variable. You have a struct, name of structure, and different data types are there, and you have different data members here, and we have various variables. Now this structure, you have made a structure, and when we have made a variable, this variable will have access to all these members. So just if I want to access this member, say this is member 1, this is var1, I'll say var1.1. If I'm just naming data member 1 as 1. So this is how we access the members of the structure. So when we want to declare the structure type variable separately, that is after defining the structure, that is structure name, then variable 1, variable 2, variable till n. This can be defined in this way also. So these both are similar. How to access the structure element? As I just suggested, dot operator. So in order to access the structure element, we use the dot operator. So this is just denoted by dot, and the general form of accessing the structure element is simply the structure variable dot, structure variable name you can say, with dot of element name. Then we come to the pointer. Now pointer is nothing but a variable which holds only the address. So it is normal variable can have 1, 2, A, B, C, D, that is string, it can have number, it can have floating values, and pointers can only hold the address of these values. So pointer is actually a variable that will hold the memory address of another variable of some type, you know. If you say integer pointer, then it will hold the address of the integer variable. So how to declare and initialize the pointers? So syntax is quite easy. You have to say data type, you have to use a star here, and variable name. So int star p, now this is a pointer p which is holding the address, which is able to hold the address of an integer variable. This p1 will hold the address of say the float variable character. This c will hold the address of character. So how to do it? See, this int a is 10. Now this is a pointer p, so p will hold the address. Ampersand a will get you the address, will take out the address of a, and it will assign it to p, and p is able to hold the address of this variable. Then there are certain pointer arithmetic we need to know. Pointer arithmetic. Pointers are what? Pointers are keeping the address of certain variable, right? So two arithmetic operations, addition and subtraction, this can be performed on pointers, but you add 1 to pointer, that doesn't mean that you are actually adding the numeric 1. You are actually incrementing to the next or going to the next memory location. So you are actually adding the size of whatever the pointer is pointing at, maybe integer, say 2 bytes or 4 bytes. So it will add to that. Each time a pointer you increment, it will point to the memory location which is of the next element of the same type, like that is the base type. So if we have a pointer, say int p, this is a pointer, and you say p plus plus, that means you're incrementing this p, pointer. So if the current address of say pointer is 1000, and just assume that integer is taking 2 bytes, so it will go to 1002, that is the p will increase to or increment to 1002 rather than 1001. So when we add 1 to a pointer, it actually adds the size of the pointer's base type. So what is the base address? Always understand that the pointer holds the address of very first memory location of array where it is pointing to. So if we have an array can have different sizes. So the first element, this is the first element of the array. The base address is actually a pointer. The pointer is holding the address of this element. So address of the first memory location of the array, this is known as the base address. How about dynamic allocation operators? So C++ have dynamic allocation. So C++ dynamic allocation operates or operators. It allocates memory from the free store, that is heap. So heap is, there are various areas like the heap, like the stacks. So the dynamic allocation operators take out the memory from the heap pool and allocate to whichever operator or whichever allocation is required. So the pool of the unallocated heap memory provided to the program, this pool is available for us. So C++ define two operators, which is the new and the delete. So these are two operators we have, the new and the delete we have. So if you correspond it to C, you will see malloc and free. So this new and delete that performs the task of allocating and freeing the memory during the runtime. Then pointers and array. As I said, C++ treats the name of the array only you have to give the name of the array. That will be only the pointer. So this is the pointer which is pointing to the base address, that is the address of the first memory location of the array. Type def is for type definition. So this type def keyword, it will allow to create aliases, means these different name for the same thing for data types. So the syntax would be something like this: type def, you have the existing data type, now you have given the new name. So type def int num means now wherever you use num, it will correspond to int only. Hash define preprocessor directive. So this hash is very important. Before going to processing, this there is certain pre-processing is going on, that is, things are being placed inside your code. So this hash defined directive, it creates symbolic constants actually, those represents this representing as macros. So now we have macros. So what are these macros? Macros are nothing but the preprocessor directive. So it starts with hash and it is created using hash, right? So this define that it serves as a symbolic constant. They are created just to reduce the amount of repetitive coding. The way you do or write functions, it's something like this with some differences. The differences are in the way they are executed. So there are various macros, not only functions, not only the way function it resembles, but also say hash define pi 3.14. So pi is what? This is a macro, and it will replace 3.14 throughout the program. Wherever it finds pi, capital Pi, it will replace the 3.14. Then we also have something resembling the function. So hash define max a comma b, a greater than b, question mark a colon b. So this defines the macro, which is called the max, and it takes two arguments, a and b. So this macro may be called like any other function. So just as an example, if you pre-process it, say max x comma y, the a will give you number which is, if a is greater than b, then if this a is greater than b, then a will be assigned to a, capital A, otherwise b will be assigned to capital B. So this is simply a is equal to x greater than y, question mark x colon y. And as I'm just saying that we will just understand that macros, the content is placed inside your code. So this is just this code, this from here to here being put in here. Okay. Function overloading. So this function overloading is the process of defining and using functions having the same name. It may have different argument layers, it may have different return types. These functions, they are differentiated during the calling process by the number of arguments, the order of the arguments, and the types of arguments which is passed to these functions. For example, see, all these functions, three functions have the same name, but the type it has are different. Means this one has integer, the other has double. The return type is also different. So